Course 3 Math. Wonderful to have you this year. Those of you who don't remember or maybe are somewhat new to videos in my class, you are welcome to pause when you need to think longer or do something else and then resume, press play. You can rewind if you didn't get something. You can fast forward if maybe you've watched it before. Make this video as useful to you as possible. It can really be as good or better than a traditional setup with a teacher standing in front of you at a whiteboard teaching these concepts in person. I am teaching them to you. I'm here as a person, but this is on your time, so you can take the best of a lecture and make it even better by taking it into more of an individual sort of setting. So this is how we do things, and if you have any questions on how to do the videos in math class, don't hesitate to talk to me. We take care of the power-ups and maybe the problem solving in class. Right now we want to talk the number line. We're going to get all the way to sequences of numbers today. We're going to review. A number line looks something like this, right? And we got 0, or what's called the origin here in the middle. Origin means the beginning of things. So you think of that the beginning, and then we go to 1, 2, 3, right? Usually we count this way. Everything to the right of the origin, or 0, is positive. We call these the counting numbers. 1, 2, 3. They're counting numbers. They're the numbers you learned in preschool when you learned to count. We add 0 when we talk about the whole numbers. Whole thing, whatever. Think about that. That's when we include 0, which looks like a whole, right? So that's the first two sets of numbers I want you to know. 1, 2, 3, 4, and so on, counting. We might call those the numerals. We might call them cardinal numbers, I think. And then if you add 0, you say 0, 1, 2, 3, 4, 5. Those are the whole numbers. If we add these numbers on the left side, what do we call these numbers? They are negative. They're worth less than 0. They're useful for like finances and debt, things like that. Then when we include negatives, that all the they can go on forever too. Technically, they have, every single negative has a pair to the positive that goes on and on. When we include those, we call it integers. That's how you pronounce that word. So counting numbers, whole numbers, integers, 3 sets of numbers for you to be familiar with. We call these sets. It's a collection of items. You can also have a set of polygons or a set of angles. It's just items that are all related to each other, so we can call it a group or set. Elements are the members of the set. So, for example, when we talk about a set of integers, an element in the set would be 0 or 3, or since it's integers, -3. The set of whole numbers, of course, we add 0 as well. You might have 3, and there's, this ellipse here we call the 3 dots, means it goes on and on this direction. So another element in the set of whole numbers that's not shown, can you think of one? How about 7? Yeah. How about 1,250? Yeah. All right, we're moving on. Absolute value we show with these lines. Try not to make them look like ones, right? The absolute value of -5 we show like this. And what that means is, what's its distance from 0? Here's where the number line really comes in handy. Absolute value means distance from 0, distance between the number and the origin, or 0. Okay? So let me illustrate for you what the absolute value of -5 is. If we look at this number line and we say, what's the distance of -5 to 0, then it's a little easier to understand why we always talk about absolute value in positive terms. Because I count 1, 2, 3, 4. How many spaces is it from -5 to 0? Like if I was jumping spaces on a board game, I would say I counted 5 spaces. We don't count distance in negatives, okay? We can call this a negative element to the set, but when we describe its distance from 0, distance from 0, we consider that a positive number. We always show absolute value, because it's distance, we always show it as a positive, like so. The absolute value of -5 is 5. Just 5. Just say 5. You would never travel negative miles. We don't consider negative spaces from 0. So negatives, absolute values turn positive. In example 1, they have you arranging least to greatest. I guess it's simple enough. If you're in course 3, you know how to do this by now. Just always be taking careful attention to what they want. They might say greatest to least or such. When you see these like circle looking things between integers or whatever, that's giving you space to show an inequality. So not usually equal sign, but less than, greater than, or that can include equals to. So again, you're arranging which one's bigger, and always eat the bigger one, right? He's hungry for the big one. Face the open towards the big one. To graph a number on a line, you would just put a dot at, say, -2. Or if I say graph the origin of the number line, I would just put a dot on 0. Because we're just graphing one point, a specific spot, no more, no less. These numbers are members of the set of even numbers, the ones that they've dotted here, right? -2 is also even. -4, 4, 2, of course. 0 counts as an even number in the set. The set of even numbers can be expressed as a sequence, an ordered list of numbers that follows a rule. I guess a sequence is usually shown with these braces, and then we show them listed with commas, right? And then this ellipse in a direction if it keeps going on going. We call it a sequence, kind of like a sequence of numbers, written out that way between braces. Graph the numbers in this sequence, example 3. Example 4, graph 2 numbers that are 4 units from 0. So what are we graphing? 2 opposites on either side of the origin that have the same blank, the same absolute value, same distance from 0. Right? They're both, count them, 1, 2, 3, 4, distance from 0. You should be able to do all of these, A through H, including the example. I'm going to be looking for that in our class time together. Please ask questions of classmates. Please ask questions of me, and always do your best.